Welcome to another video. In this video, we are going to look at the proof of Cramer's rule. The Cramer's rule is used for solving the system of linear equations. Before knowing what is Cramer's rule, we have to know what actually is solving of linear equations, okay? So, if we have set of linear equations like this, which has the unknowns, which are called variables such as x1, x2, x3, and if we have the number of the equations equals to number of unknowns here. Here the unknowns are x1, x2 and x3. There are 3 unknowns and there are 3 equations. So if we solve this for the value of x1, x2 and x3, each of the equation it will get satisfied, which means that by substituting the value x1, x2 and x3, it will be equal to d1 and d2 and d3, okay? So this is the analytical explanation of this solving system of linear equations. Now moving to the graphical representation, we know that this system of linear equations means that it is the polynomial of degree 1. So any polynomial with the highest degree 1 is the linear equation. So with this will result in line, right? So if we say that our equation 1 has resulted in this red line, our equation 2 has resulted in this black line, and our equation 3 has resulted in this blue line, then at the point x1, x2 and x3, all these 3 lines would intersect. So this intersection point is the solution for the system of linear equations, okay? By utilizing the coefficients of our variables for this system to have a unique solution, which is the actual solution at which it satisfies the equation as well as the lines intersect, then the determinant should be non-zero, which means the determinant of the coefficient of the variable should not be 0. Otherwise, if it is 0, then there will be no solutions or there will be infinitely many solutions, okay? Without further ado, let's start our proof, okay? Now for the Cramer's rule, we will make use of determinant and determinant properties to evaluate the determinant of coefficients of the linear equations, okay? Now what we will get is that first we have to create a determinant by utilizing the coefficients of the linear equation, okay? So we have that if d equals to determinant of all the coefficients of the variable, okay? Here our d is the determinant of the coefficient of this one. Now what I will do is I will utilize the properties of determinant that if I multiply any entire rows or columns by some scalar k, then our new determinant will be k times the value of our old determinant, okay? Therefore what I will do is I will multiply c1 by x1 of c1, okay? So our new determinant will be x1 times the determinant, right? So this is very important. So this is one of the very important properties of determinant. So it will be, now what I will do is I will further evaluate or operate this column 1 by multiplying the column 2 by x2 and multiplying the column 3 by x3 and adding to the column 1. That I will do operating c1 by x2 c2 plus x3 times c3 and I will add it to column 1, okay? By doing this, you know that from the determinant property that if we multiply the rows or column by the scalar and add it to some rows or column, then our determinant will remain unaltered, right? So that by performing this, our determinant value will not change. Therefore, my determinant will be x1d equals to, so we are making use of the properties of determinant. Now, if you observe very carefully here, in C1, what we have got is this one, right? So if you observe very carefully and compare this determinant and this, we know that this C1 has the form this one, and this one. And this whole expression is equal to what? It is d1, d2 and d3. They are the sum of the product of the variable and the coefficient, right? Therefore, I can replace this one with d1, this one with d2 and this one with d3, right? So by doing this, I will get x1d equals to determinant of d1, d2 and d3, and I will get b1, b2, b3, c1, c2, c3, right? Therefore, if you observe very carefully, this determinant is similar to our original determinant, but for this c1, for this coefficient of x1, we are replacing with the sum of the equation, right, which are d1, d2 and d3. Therefore, to find the value of x1, what we need to do is just we need to divide this determinant by our original determinant. Therefore, what I will do is that I will rename this determinant as dx1, okay? Because this is the determinant which the column containing the x1 coefficients are replaced with the sum, right? So if I say dx2, then it means that it is the column which contains the coefficient of x2 but replaced with this d1, d2 and d3. And if I refer as dx3, then it will be the column which contains the x3 coefficient but replaced by d1, d2 and d3, okay? Therefore, I can rename this whole determinant as x1, okay? Then I will divide this with our original determinant. Therefore, we get the value of x1 by doing this. Therefore, we will get the value of x1 by taking the ratio of the determinant, which the column containing x1 variable is being replaced by the sum d1, d2, d3 and our original determinant, okay? This will work similar for our x2 and x3, okay? So let's do it very quickly now. For x2, what I will do is c2 by x2 times c2 such that I will get, then I will operate c2 by adding x1 c1 plus x3 c3 plus x2, then I will get a1, a2, a3. So this value is just d1, d2, d3. So this matrix is x2 d, right? And this is also x2 d. So what I will do is I will substitute this here. So I will get x2 d equals to a1, a2, a3, d1, d2, d3 and c1, c2, c3 determinant, okay? So what I have said is that earlier I have renamed this as dx1, so here this is dx2, which means that this is the determinant which column containing the x2 coefficient is replaced by the sum, okay? So our x2 will be now dx2 upon d, okay? And for x3 also it is similar. c3 is x3 c3, okay? So we'll get x3 times d equals to a1, a2, a3, b1, b2, b3, x3 c1, x3 c2, x3 c3, okay? And similar to this, I will operate this c3 by multiplying x1 with c1 plus x2 with c2 and adding to c3, okay? So by doing this, I will get x3d equals to a1, a2, a3, b1, b2, b3, and here I will get, so if you observe carefully here also, these are d1, d2 and d3, okay? So it is just a1, a2, a3, b1, b2, b3 and d1, d2, d3. This is dx3, which means that this is the determinant whose column containing the coefficient of x3 is replaced by this sum, okay, d1, d2 and d3. Therefore x3 equals to dx3 upon d, and these are the values for x1, x2 and x3, and this is the Cramer's rule. Therefore Cramer's rule says that for the system of linear equations containing 3 variables and 3 equations, our values will be simply x1 equals to dx1 upon d, x2 equals to dx2 upon d, and x3 equals to dx3 upon d. Okay, in next video I will solve some problems involving the use of this Cramer's rule. I hope you all would have enjoyed this video, and I'll see you in next video. Thank you.